Hello and welcome to the Side One YouTube channel. My name is Ray, and in this video, the Raspberry Pi Robo Hat Part 7, we're going to finish off the construction of this circuit board by installing the through-hole components. Now I am waiting on some parts still, which is a bit of a problem. That's this right angle single row header. This is actually one I've recovered from another device. I don't have any other spare ones at the moment for this second one, but I can install one and that will allow me to move on to testing anyway. If testing is successful, and I'm hoping it is, I'll start building up the next board. Some of the differences I will make when building up the next board is I will put all of the passive surface mount components on first using the hot plate method. That is putting the solder paste on all of the little holes, not holes, on the little pads for the resistors and capacitors, and installing those in one go. And then coming back and doing each of the surface mount semiconductors one by one. I think that's the easier way to do it, but they'll be done off camera anyway. So let's get on to this one, and I should have already turned on the soldering iron. So with this one, I have two single row straight headers pins that's going to go into here. The idea for those ones is they mate up with the daughter board and this socket here. We will need to also have standoffs, and I've already mounted them on here temporarily. They separate the boards at the correct distance and allow everything to plug together. And I'll be using this Raspberry Pi 3, which I have already mounted on a board here, although I could replace it with this Raspberry Pi 4, but I'll save that for another time. The board is compatible with either directly. I think there's a design change for the new hat designs to suit the Raspberry Pi 5s. This cutout here is a little bit bigger for the Raspberry Pi 5s. So my soldering iron is up to temperature, so I'm going to need solder, the iron, and we'll start putting in these headers. So what I'm going to do with this one is poke these through first. Actually, no, I'll do the outside. Let's start with the I2C connector. So this has I2C. Actually, I've actually labelled it on the bottom. I have the SEL SDA ground and 5 volt for the I2C. And I think from memory, I have the I2S connections on there as well. So I2S is for sound systems. So let's start by putting those ones on first. That's a bit better. So one of the things I like to do is do the diagonally opposite corners first, and that makes sure you've got all of the pins in the right spot, and it'll hold everything else in place. Oops, that didn't take it all. And I'll put this one on the other side. Okay, so that's those ones. Now I just used that header to align those pins, make sure they were okay. And I might put the 12 channel capacitive sensor header in next. Might see if I can get this one in as well. This is the 8 channel digital I/O. of the PCF 8574. Okay, that's all of those. Okay, so the next one I need to do is this header. And for that header, what I'm going to do is actually poke these in to the 40 pin header for now. There is method in my madness here. I'm going to poke those through like so. And that holds those pins straight, level and together. So it'll make it easier to line up with the daughter board later on. Okay, so now I can pull this header off. And that's ready for the daughter board to plug onto. Right, so we'll put this header on the bottom now. That's the one that plugs onto the Raspberry Pi. Right, that's all the corners done. So we'll just go through and solder up all the rest of the pins. Now in truth, most of these pins are not being used. They look alright. So that's this board. Now there is some test points on the underside of this board. They can be used with pogo pins, or a combination of pogo pins and this header. But I don't actually have the equipment handy to be able to do that. I could put a little 2-pin header in on this JP1, and I may do that down the track. The EEPROM that's mounted there, which way has it gone, is not actually programmed yet. In fact, I haven't worked out what the program's going to be. It's connected to 2 of the pins on the Raspberry Pi header, the I2C and the SCL and the SDA for the I2C bus 0, and they're actually reserved pins for this chip within the Raspberry Pi hat specifications. And the idea is there is essentially a file structure needs to be installed onto the chip, which tells the Raspberry Pi during boot up how to configure the IOs on the header board on the GPIO. So I will work that out at some stage, and I'll also post that file and make it available. Alright, so next trick for this one is to install it onto a Raspberry Pi. So I've got this Raspberry Pi 3. Now this has standoffs already on it, but in total when assembling a unit with a Raspberry Pi, you will need 8 of these standoffs. Now these are hexagonal M2.5, so thread enums M2.5, 12mm long. The thread sticking out the end, I'll pull this one out so it's easier to see. So they're 12mm long, and the thread section is 6mm long. It's all M2.5. There are 4 goes between the Raspberry Pi and the daughter board, which I've already got installed in here. Just put this back in the pack so I don't lose it. I've got more of them coming too. Seem to have a lot of stuff on order. Now for initial testing, technically I don't need the daughter board on. I have done basic multimeter testing already of the primary traces that that could potentially cause me grief, and I've actually removed or wicked out excess solder as a result. Mostly on the secondary board. The daughter board came out pretty well. So these then screw into these headers. Yeah, the names on these boards are actually the patrons I had at the time when I designed the boards. And we've got Go Lucky and Lorenz Berger were both my VIPs at the time. Go Lucky is still with me. And Elmerels 45 and White Wolf were my builder patrons. And Elmerels 45 is still with me. And now we use the screws to hold that down. These are M2.5 by 6mm long screws. Okay, so that's all assembled. I have got a printout somewhere, but on the back of the boards, I did actually write down what most of the pins were and what their functions are. I didn't for the touch input or digital I/O because I think I was just short on space. But we have got the SCL, SCA, ground and 5 volt are the upper set of pins here, and the I2S are the lower set of pins. Alright, so let's get some power for this. See if I can find a longer lead. Now I have a red LED on the corner there. Don't appear to be getting much activity on that LED, which is not a good sign. I think my connector might be getting a bit dodgy. Alright, I'm going to remount the Raspberry Pi 4 onto that board and give that a try. And I'll be back in a sec. Okay, so I remounted this on the Raspberry Pi 4 and I did a bit more testing and it wouldn't boot up as well. So I did a few tests with the daughter board off and discovered that I was getting 0.7 volts on the 3.3 volt line. So I thought the problem might have been over by the LED. I wasn't sure if I had it back to front or not, so I've just pulled it off the board. That's it there. And I was only getting 0.7 volts still, so that's still a problem. So I started having a closer look at all of the pins on the chips, and when I looked at the PCF 8574, the pins on the top side, I've got this basically orientated around the other way. Actually no, I've got my camera flipped. Let me just go into that's better. So when you look at those pins on the top side of the chip there, they all look pretty good across here. All those pads are very nicely aligned, they're all soldered well, and there's no bridges. I spent a bit of time on that because there was a solder bridge there the other day. But why is my camera frozen? Okay, so when I had a look at the board down the bottom here, or this chip, I discovered these pins are misaligned, and that could potentially be where my issue is. So I'm going to have to do a little bit of rework on that. So I'll rework that chip, and when we're looking for a problem like that, we just need to go through and check every component and make sure they're on. I've got a little bit too much solder here, in fact, and he's pretty solid on there. A few of these. What looks like a cat's hair. I hope that chip's alright. I did have some shorts over here and I thought I cleared those shorts. That one looks easy enough. I think I've got that one there in roughly the right spot. That one looks like it's in the right spot. So I've only got the one that looks like it's not quite connected the way it should be. And there could be a short in some of those pads. Alright, so after I've done a little bit of reworking, I'll come back. I'll test this up and I'll go over all of the problems I did find. I think most of it's going to be my soldering work on the surface mount devices. I do need to do this under a microscope, and I'm having trouble keeping the video recording through the microscope going at the same time, which is problematic. So I'll sort that out and I'll try and get that LED back on and verify that that's working as well, and then we'll come back with the testing with the program. Okay, so I've tracked the problem down and it was the PCA 9685. So when testing with a multimeter, I was showing no shorts, so while the soldering is not brilliant on the PCF 8574, it's not where the short was occurring. Testing with the multimeter showed there was no shorts between 3.3 volt and ground. So I went to the next trick, and that was to use a thermal imager and apply power. So this is my thermal imager. I have actually got a video where I've unboxed it. It plugs into your mobile phone and allows you to view an image. It's fairly high resolution, so I'm actually quite impressed with it. And it showed that this chip, which was mounted here, was getting hot in the middle. I've removed that chip off using hot air and plugged it in, and what I'm seeing is the Raspberry Pi now starting to boot up. So that proves conclusively that that chip was a short circuit. I'm just going to put this board on top. I'm not going to secure it down properly at this stage, and plug it in, make sure that it will start to boot. And I am seeing a green light on the power LED, but it's very dull, so I may have an issue on that board as well. Definitely not getting enough power for it. I do have another power supply that supplies more power. Try that. No, I've still got a problem. So that's my next one to hunt down, find out where my short is there. And hopefully I didn't damage the Raspberry Pi 4 while I was doing that. Did get very warm in around here somewhere. But so I can't continue with that until these parts turn up. They're still on back order. They should have already been here, but they haven't arrived, and I'll go through and see if I can find any shorts in this board. To see when that video comes out, don't forget to click on like, subscribe, and ring that notification bell. It's a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to support the channel further, I do have a Patreon account, and you can join my VIP patrons Go Lucky, my All Access patron Jeff Jerd, my Builder patrons Elmorales 45, Andrew Cardone, Airgar 69, and Stefan Paps in supporting the channel. I also have YouTube membership if you're interested in supporting through that way as well. If you've got any questions, feel free to drop a message in the comments below, or drop into my Discord and ask a question in there. I do check that very regularly. If I can't answer your question, someone else might be able to. And we'll see you in the next video.